Circles are everywhere. Traffic lights, cups, the moon. They're actually all over the SAT too. So if you want to ace the math section, you'll have to know all about them. But have no fear. I'm here to cover them with you in their entirety as they relate to the test. Specifically, we'll go over circles, chords, arcs, and sectors. As you probably know, a circle is a round figure with points equidistant from its center. And the radius is the straight line distance from the center of the circle to the outline of the circle itself. Once we know the radius, we can plug it into the formula for the area of a circle, which is area equals pi times radius squared, usually referred to as pi r squared. All right, we've got a couple key basics down. Now, before we dive into a real test example, let's work our way through a little practice problem that will help us define the other terms we need to know. If the circle below has a diameter of 32, what is its area? We'll underline the facts and circle the key words as always. We're told that the diameter is 32, but in order to find the area using the equation a equals pi r squared, we need the radius. Okay, we've broken down the question and pulled out the information we need. Now let's work through the problem. The diameter is a chord that goes through the center of the circle, and a chord is a line connecting the edges of the circle. Returning to our problem, let's use the diameter to find the radius. Because the diameter goes through the center of the circle, we know that 1/2 of our diameter is equal to the radius. In this circle, 1/2 of 32 is equal to the radius, so our equation is 1/2 times 32 equals r. Doing the multiplication, the radius of our circle is 16. Label it on your picture. Now we can plug our radius into the area equation, which gives us area equals pi times 16 squared. A little bit of multiplication, and we find that 16 times 16 equals 256. Then multiply by pi. We get area equals 256 pi. We've learned about chords, diameters, and areas. Now let's take a quick look at the circumference of the circle. Its formula is also included in the formula box. Circumference is similar to perimeter as it measures the outside line of a circle. However, the formula is different because circles don't have straight sides. The equation is circumference equals 2 times pi times the radius, or diameter times pi. So for the same circle with radius 16, our circumference equation becomes 16 times 2 times pi, which gives us 32 pi. And if we were only asked for the area of a sector, or part of the circle, we would use a different formula. Area of the sector over the total area is equal to the central angle divided by 360. The central angle is the angle between the two radii that define the sector, in this case labeled x. Just like the area of a sector is in ratio with the total area, the arc length of a sector is in ratio with the total circumference. So to find the arc length of a circle with central angle x, as shown here, we use the equation arc length over circumference is equal to central angle over 360. Those were a lot of circles and formulas, but luckily you can use the formula box provided by the SAT for most of it. Keep practicing to make sure you understand how to apply the formulas and you'll be set for the test.